Here we have a SAT math problem. Okay, let's cover the question. In the figure above, what is the area of the square? That is shaded region. Here we have the shaded region. We have to get the area of this square. Okay, let me assume x as the length of each side of the square over here. Now to get the area of this square, we have to get the value of x, which represents the length of the side of the square. So once we get the value of x, it has to be squared. That is x square gives the area of the square. Okay, how do you have to get the value of x? Okay, let me draw a radius to this circle over here, and also let me draw one more radius over here and an horizontal line segment over here, and we have right angle. And since the length of this part is x and the length of this part is also x, we know that this is a radius and its length is 5 centimeter. When the length of this part is x, then what is the length of this part? Then it has to be 5 negative x. That is, we have to subtract this length from the total length, that is the radius of the circle, 5 centimeter. And let me assume y as the length of the horizontal line segment over here. And we know that this is the radius of the circle, its length is 5. Now let's use Pythagorean theorem in this right triangle. That is, sum of the squares of two legs equals to the square of the hypotenuse. Okay, let me do it over here. That is 5 negative x whole square positive y square equals to the square of the hypotenuse, that is 5 square. Now we can get the expansion of the square of the binomial using the algebraic identity, that is a negative b the whole square equals to a square negative 2ab positive b square. This is the expansion of the square of the binomial a negative b the whole square. When I consider the square of the binomial over here, this one is exactly in this form, a negative b the whole square. At the place of a we have a 5, at the place of b we have x. Now let's use this trinomial to get expansion for this square of binomial. Then we get 5 square negative 2 times 5 times x positive x square positive y square equals to 5 square on the right side. Let me subtract 5 square from both sides, because we find 5 square on both sides. Positive value, negative value will cancel. The same here. We get negative. The simplification of this one is 10x positive x square positive y square equals to 0. Okay, now let's solve for y in this equation. For that, we have to get rid of this negative 10x and positive x square. Let me add 10x to both sides. Let me do it. And also subtract x square from both sides. Let me do it. Then this negative value, positive value will cancel out. Positive value, negative value will cancel out. I am getting y square equals to 10x and negative x square. Since my aim is to solve for y, I have to get rid of the exponent 2. For that, we have to take square root on both sides of this equation. And on the left side, the square root and square will cancel out. Usually, when we take square root on both sides of an equation, one of the square roots will cancel out. And for the other square root, we have to consider positive or negative sign. But here on the left side, we have y, which is the length of one of the legs of a right triangle. So the length of one of the legs of a right triangle can never be negative. So we don't have to consider positive or negative sign over here. We can consider only positive sign. So then I'm getting y equals to square root of 10x negative x square. Okay, now let's do the same thing in the second circle. Let me draw a radius over here and a radius over here, and let's form a right triangle over here. Since both the circles have the same radius of 5 centimeter, so whatever stuff we have taken over here, the same stuff we'll have over here in this circle also. I mean in this right triangle also. So we'll have right triangle 5, and this length is x, and this part is 5 negative x, and also the length of this horizontal line segment is y, because that's what we have taken over here. Okay, now let's consider the length of the the length of this horizontal line segment over here. To get the length of this horizontal line segment, I have to add this y, x, and y. So that is we get y positive, x positive, y. And whatever length you have for this horizontal line segment, the same length you have for this one as well. So that is 10. Okay, now when I simplify over here, I'm getting 2y positive x equals to 10. Now let me subtract x from both sides of this equation. Then this positive x, negative x will cancel out. I'm getting 2y equals to 10 negative x. Our aim is to get the value of x, in particular x square, which gives the area of the square. Okay, now let's replace this y by the equivalent stuff. We know that y equals to square root of 10x negative x square. Let's plug in this one now for y over here. Then I'm getting 2 times square root of 10x negative x square equals to 10 negative x. Now to get of the square root, we have to square both sides. Let me do it. Okay, here two values are multiplied and we have the common exponent too. Whenever two or more values are multiplied and there is a common exponent, the exponent can be taken separately for each value and multiply the results. Then I'm getting 2 square times square root of 10x negative x square the whole square. And here we have the square of a binomial. We can get the expansion using the algebraic identity over here. Then I'm getting 10 square negative 2 times 10 times x positive x square. Okay, here the value of 2 square is 4 and the square root and square will cancel out. I'm getting 10x negative x square equals to 10 square is 100 negative 20x positive x square. Okay, we can distribute this 4 to this 10x and negative x square. Then I'm getting 40x and negative 4x square equals to 100 negative 20x positive x square. Okay, now we get a quadratic equation over here. We have to write this quadratic equation in standard form so that we can solve for x. Standard form means ax square positive bx positive c equals to 0. So in this form, we have to get this quadratic equation and solve for x. Okay, now let me erase the stuff and continue the problem. This is the last step of our previous work, and I'm going to write this quadratic equation standard form. If you want, you can use the Desmos to solve for x in this quadratic equation. I'm going to solve it manually because it's not too difficult. Okay, now let me subtract x square from both sides and add 20x to both sides and subtract 100 from both sides. That is, my aim is to get everything on one side of the equation. Okay, here this positive x square, negative x square will cancel out. This one will cancel out. This one will cancel out. When I combine these two, I'm getting 60x. When I combine these two, I'm getting negative 5x square. Then we have negative 100 equals to 0. Let me write the x square term at first. Then I'm getting negative 5x square. Then x term positive 60x, negative 100 equals to 0. Okay, here when I consider the coefficient of x square, coefficient of x, a constant term, everything is a multiple of 5. Since the leading term is negative, to get rid of this negative sign, let's divide all the terms of this equation by negative 5. Okay, let me do it. Here we have negative 5. Here we have a negative 5. Okay, the negative 5 will cancel out. I'm getting x square. And negative times positive is a negative. When I divide 60 by 5, I'm getting 12. That is 12x. And here negative times negative will become positive. 100 divided by 5 is 20 equals to 0. Now we have to solve for x in this quadratic equation. I think it can be solved using factoring. For that, we have to multiply the constant term positive 20 by the coefficient of x square. In this case, it's 1. 1 times positive 20 is 20. Okay, now we have to get two factors so that the product of two factors equals to positive 20. And the sum of the two factors equals to the coefficient of x, so that is negative 12. I think negative 2 and negative 10 will work. When we multiply negative 2 and negative 10, I'm getting positive 20. When we add them, we get negative 12, which is the coefficient of x. Further, we have to divide both the factors by the coefficient of x square, that is 1. Still, I'm getting the same values, negative 2 and negative 10. Now, to get the two values of x in this quadratic equation, we have to change the sign of each of these two factors. Okay, now let me consider the first factor, that is negative 2. When I change the sign, it will become positive 2. And now to get the second value of x, we have to change the sign of this factor, then we will get a positive 10. Okay, I'm getting two values for x. One is x equals to 2 and other one is x equals to 10. Is it possible to have this value 10 for x over here? No, it's not possible. Even when I add the radii of two circles, that is equal to 10. But there is no chance for the length of one of the sides of the square is 10. So we can reject this value. So the length of one of the sides of the square is possibly 2, that is 2 centimeter. Okay, now let's get the area of the square. Let me write the stuff over here. We know the formula that the area of the square is the length of one of the sides of the square has to be squared. We know that x is the length of each side of the square. It has to be squared to get the area of the square. We know that the value of x is 2. Let's plug in 2 for x over here. Then we get 2 square. Then we get 4. That is 4 square centimeter. Therefore, the area of the square, the shaded region is 4 square centimeter.